I'm nervous. I am really nervous. Let's see here. We are on the second loop here. Thanks for coming down and hanging out with me in the basement today. What we've got is a major brain transplant on this extremely early Proto Sound 1 MTH GP9. So the problem with this is right now it is a brick. It does not move forward or backwards. When you engage the throttle, it just kind of doesn't even rev up or anything. It's just like you're not even changing the throttle hardly. How do I know that this is an early Proto Sound 1, besides just looking at the date code or something like that? What features make it a very early Proto Sound 1? Well, this engine surprisingly has a switch on the outside, on the underneath of the frame, for the battery. Because the bottom board here cannot shut off the battery when you remove power. So it's like a very early beta or very first generation Proto Sound 1. I thought that would make this immune to the Proto Sound 1 issues, but hey, it succumbed to it, and that's okay. I mean, this thing's built in '93, so it's quite old by now, and this is a very high noisy environment that it lives in, so kind of understand why it doesn't last. But there are people that have had these last a long time. I've got my favorite engine here, which is this guy. This is Proto Sound 1, but it's much later. And this guy's still humming along really good. I am very happy and not worried about it. Let's get started, and we'll talk about the plan as we go. Okay, so here is the 12 amp unit. I could have gone with a smaller unit, but on their website, and this is not a sponsored video, by the way, Dallee Electronics, or Dallee Electronics, they tell you to plan for the maximum amount of current. And you say, wow, this thing only draws like 3 amps when it's running around. What the deal? What's the heck? What's up with that? The thing is, maximum current means putting this on the track, holding it, giving it more power, and you'll see those amps rise past 6 amps. I would have really liked to have tried the Blue Nami setup, except the Blue Nami does not have conventional mode. I would have had to use my phone all the time to operate this locomotive, but because it has 2 motors, it can easily exceed the current of the Blue Nami unit. I could have went with a smaller unit here, but for not much more money, like $10 or $20, I don't remember what it was the difference between this unit and the next smaller one. So, let me look at their literature here. This thing came with some of the catalog pages. Let's see if we can figure it out here. Yeah, alright. Here's their pages. So they use a 4 amp, a 6 amp, and a 12 amp. So I could have went with 6 amp, but it would have been right at the limit. And I like to run things hard. I don't want to, I might break it. I just love having things be nice and strong, so that's why I went with the 12 amp board. But we will, in another video, we're going to do some testing on this guy after we get this installed. We'll try hooking up the motor. Well, the motors I will hook up in parallel, so plus and minus from this get tied to plus and minus on this guy to the board. So first thing we got to do is we're going to remove this setup, and then we're going to cut the wires close to the board so I can see where they go. What's nice on this one is we do have a constant current voltage board here to run the cab lights, so I'm going to leave that circuit alone. I could run it through here. You can do directional lighting through here, which I'll eventually do with the ones on the shell here, the headlights. But we will have no sound when we're done, unfortunately. But like I said, this is a very basic unit, only had engine sounds, horn and whistle, or horn and bell, excuse me. That was it. All right, so let's take that screw out. And just in case I learn about these and end up fixing it or getting a replacement board, we can put it back in. I already removed the heatsink from over on this side, so this end of the board is clear. We got some connectors. I'm not going to chop any of these other wires. I'm going to leave these hanging out in here because, that's all right. We don't want to lose anything. We might modify this locomotive more. So let's see here. The big ones are going to be the motors. Grab my cutters here. Determines where the power goes, front coupler or back coupler to disconnect. Alright, so here's the board. I did test this board, or I did test the sound chip in my Galloping Goose. I did not want to swap boards with the Galloping Goose. I did not want to make that inoperable. But the sound chip from this did work in the Galloping Goose, so sound chip was good. I was kind of surprised. Now, plan is kind of get everything out of the way. We're not going to use some of this, but we want to save it. So how do I want to mount this guy? I wish I could go right like this, but I can't. This is too wide to fit in here like that. Just a little bit too wide. But it'll fit just fine sideways. Actually, it's kind of a tight fit like that too. Like right tight. That's okay. We can make it work. So what I need is to make an L bracket and have this guy be something like this. I think that would work perfect. Could even move it back a little bit. No, the wire's got to come in the bottom though. We got a bracket there, which we can screw to. Let me come up with something. We'll see how it goes. Alright, let me show you what I got done so far. This is the material I chose to make my bracket with. This is speaker material. It's actually off of a pinball machine, I think, or maybe a jukebox. Probably a jukebox. Not sure. Don't remember. But I picked this because it was easy to form. I do have some aluminum, which is superior for its heatsink ability, but it's harder to form, and it was thicker. This is thin. I just took it out to the vise, measured it, and bent it. I'm going to drill a larger hole there. I'm going to have this be elevated because we have a lot of height that can be in here. I chose a bigger piece to kind of help with the heat sinking. Now this isn't going to get red hot. I'm probably never going to get this thing hot with this locomotive, but it's good to be ready to go just in case something happens. And I want it mounted up because, of course, the way this terminal block is, the screws go in the bottom, and it'll just be a whole lot easier. I'm mounting it this way. I could mount it this way, I suppose. I never thought of that. It's not a bad idea. I'm going to probably need to carve a little bit away for the speaker because I'll be leaving the speaker in the locomotive. Won't be using it, but I'll be leaving it. Would be easier to run wires out the top. Maybe I'll do that. See, this is why you just think about stuff and talk about it loud. I'm going to secure it in this hole right here. And I've already got a screw and a locking nut all ready to go. So we're going to have one screw like that. And we'll probably mount it like this. Then I'll just have to figure out the spacing. Alright, be back when I'm ready. Here we are. I've got, this is the wire for the rear coupler. That's all tied up and out of the way. Got the wires for this volume and the speaker kind of wrapped up and out of the way. Got our wires for the motor here. Wires for the motor here. And we've got our track power with these wires. And we're ready to apply some heatsink compound. Like I said, I'm not really worried about this guy getting too hot. It's these guys that are going to get hot, but nothing I can do about that. We'll just dab a little bit on here. Just want a kind of a thin coating. That'll help transfer any heat that is developed up in here. And I decided to run the wires on this side of the fence, keeps them out of the way of the chassis. As you see, they've been smashed quite a bit before. So we just go around to this side here. See it. Heatsink compound doing its thing. Well, this is looking pretty good. I'm really happy with this so far. I had no clue how I was going to do it before I started. Just kind of making it up as I go. This screw is well supported throughout the board, so I can really crank it on there. So how these little blocks work, it's got a little sliding piece that goes down and pinches the wire. Don't want to do it too tight. Don't want to damage this block. Though because it is a through-hole component, it could be replaced. Okay. That's good. Alright. We'll see if I can carefully strip these wires. These wires are a little more, the insulation's a little softer on these, so it shouldn't be too bad. Ah, they're nice copper wires too. We'll just do them all. It's a nice little tool, vice grip. Good for working on small wires like this. Alright. This is going better than I expected. Okay, so track power is the middle ones. Just looking at my wiring here, we got brown, yep. Orange is the center rail pickup. Gonna twist the wires. And carefully put it in. That is it. It is ready for a test. Let me clean stuff up. Moment of truth. This is the first test. Let's see how everything looks here. This will be for the lockout when I get to that step. Got some extra wire nuts here. They're okay. They're out of the way. Wires don't really get too tight. Let's look at these. I'd say that's pretty darn good. Alright. Now, if one motor wants to go forward and one motor wants to go backwards, then I just swap the two wires. Blue will go to this one for this motor, yellow will go to that one. Okay, we are on this loop. I'm nervous. I am really nervous. Let's see here. We are on the second loop here, so let's get you up here and let's see if we can get you a view of the transformer. There we go. Alright. Holy moly, it works! Here's neutral. Woo! Yes! Wow. Yeah, look at that. Just like hardly any voltage and she's moving. That's 5 volts right there. Wow. Let's look up some lightweight cars here. Alright, she is moving. Wow. Let's get her a little more juice. Yeah, this is going really good. We're at 7 volts. Oop. Paper on the track. Flashlight's holding it down. Alright. Yeah, she's running good. Nine volts. Alright, let's get you a track side. I'm really happy with that. 12 volts there. That is nice. That is really nice. Wow. And it's got the 3-position electronic, reverse, forward, neutral, reverse. Yeah, that works really good. I'm happy with that. I should button up a few things and put the shell back on. It's another day. And I've made some additions here. We've got the wire hooked up here for the reverse lockout. That's going over to my battery on off switch, which I don't need that anymore. And then I've hooked up these other pigtails, and I pulled these from the circuit board here, and those go into the lighting harnesses for the engine. There's 2 actual individual bulbs in the front and 2 in the back, which is kind of cool that they do that instead of having like a light pipe or something. Let's do a little experimenting. Let's see, let's get these cars out of the way. We'll turn on our transformer. Okay, I'm going to hook up our lights here. Hopefully it won't be too difficult to do. There's that one, and this guy spins around this way. Alright, got some extra length on the harness, which is good. Now, we'll hold it like this, and we'll see if it comes on if we go forward. We want this headlight to turn on when we got forward, otherwise we gotta flip them around. Hopefully these will be directional. Wow, those are bright. Okay, so they appear to be reversed. Maybe these bulbs are like a little different lower voltage. I don't want to burn them out, but let's try that again. That looks better. Okay, let's set the shell on. Take it for a slow speed run, and like I said, I don't want to burn out these headlight bulbs. think I burned out the light. I bet I burned out that light. It is what it is. I should have paid more attention. I bet I burned it out. They must be a much lower voltage. Alright, so what I discovered is MTH used 2 miniature light bulbs in these plastic assemblies for the headlights, and one light bulb was burned out on each end, so I combined them and I put them in series here, and it works pretty darn good. Let me just try it out here real quick, make sure it still works. Okay, here's our bulbs. No, gotta be on the right track, dum-dum. Alright, there we go. So, they work pretty good. So I will be able to get the front headlights working as intended. For the rear headlight, I'm going to use one of my 12-volt bulbs here, which are dim and much, much larger. But I think I can either glue it or put some heat shrink tubing around here to keep the bulb on the side, and that'll at least give me some illumination. And again, I can change this later. I could do LED, but I like the look of incandescent. Okay, watch the amperage meter on the left dial, and I'll hold the engine and I'll give it full throttle, and you'll see that it'll actually go over 6 amps. So it actually went up to 7 there for a brief instant. So another feature of this electronic reverse unit is it's got some either software in it or it's got something in it. So if you get a little bit of dirt on the track and the power is interrupted momentarily, this engine doesn't drop into neutral. I'll demonstrate by hitting the button here. See, if I hit the button short, it doesn't drop out. I have to hold it a little longer to get it to switch modes. And another thing is, my other light, because I used orange heat shrink on it, I get an orange light. Which, that's okay. It's only temporary. I'll change it eventually. I'm sure those front headlights are not long for this world because they look pretty darn bright, but at least this thing's going. Here's the wrap-up. Am I happy? Definitely. I have a working locomotive that's not a shelf queen anymore because it was basically a brick. I was unable to use this engine, and I understand about the Proto Sound 1, and I don't really feel like I caused the issue. It just happened. They are known for it, and that's okay, and I accept that. I got this engine for a reasonable price on eBay, and I didn't get as many years out of it as I would have liked, but hey, that's the risk you deal with. Difficulty in installation. Well, because I chose the largest unit available, it was $20 more than the 6 amp version. It was a little more tricky to install, but not too bad. I really enjoyed problem solving on this to get it to fit in there properly. So, I'm happy. This locomotive works great. I gotta do some figuring out with the headlights, because that's what I like to do. I'll probably end up buying some miniature bulbs, probably, well, 12 volt, maybe 10 volt range. They're probably like grain of rice bulbs, I imagine, because those are really tiny. But that'll be something for later. And we'll also do another video where I investigate hooking up the motors in series versus parallel, because with this larger board we've got those terminal screws, whereas the smaller board does not. So stay tuned for that.